Hey, welcome to the Manufacturers Make Strides podcast. I'm your host, Martin Griffiths. Today I'm interviewing Vin Kettay and Brian Gullette of Vectra Automation. And they've created the first robotic process automation platform specifically targeted at automating the process of generating engineering drawings from 3D CAD models. I feel the pain of this process because my first job out of college, I'm sure this was the same for many engineers, was creating those 2D draft drawings for guys in the factory from 3D models that designers had made. It's quite a painful, repetitive process. You have to be extremely detail oriented, and however hard you try, mistakes slip through. It goes into if a quality inspector checks it, you just get a rap on the knuckles and have to redo it. If it slips through, it means mistakes in the actual manufactured goods. Brian and Vin from Vectra, they think that there's multiple benefits to applying RPA to this process. It can massively cut down the time and lead times of new product introduction. They think it can also massively improve productivity because less mistakes get through, so less scrap, less rework on those initial manufactured products. So let's get into the podcast interview straight away. They give us lots of background to the subject, and we get to see what the process looks like on the screen. So it's really interesting. Let's see what they've got to say. So hey there, we've got Vin and Brian along today from Vectra Automation. How are you guys doing today?
Doing just fine, Martin. How are you?
Doing well,
Great.
thanks.
Brilliant. Yeah, great. Really great to hear from you guys today. I'm really interested to hear some more about robotic process automation today. So could you just tell me how did you find out about robotic process automation? What inspired you to create a business around that?
I'll take that. So we actually got started on automating the process of engineering drawing generation well before the term robotic process automation was even became popular. So we started out at Vectra as a design services company back in 2005, and we were supporting the tier one suppliers of major automotive OEMs like GM, Ford, and Chrysler. In terms of supporting our clients, they would do the engineering 3D CAD models, and then they would send it over to our team in India, who would create the two-dimensional engineering drawings. So think of the engineering drawings as being the bridge between design engineering and the actual manufacturing process. You need two-dimensional engineering drawings with a lot of notations and dimensions and so on in order that they can actually manufacture the parts. So that's how we got our start. So when we got started, it became pretty obvious that it was a very time-consuming, error-prone, chaotic process. And at Vectra, we just decided there had to be a better way. And the obvious way of making a process better is to introduce software to automate the process. Well, that's easier said than done. It's a simple concept. You automate what you're doing manually, but to actually automate the process, we had to develop very sophisticated algorithms which had never been developed before, and we also leveraged existing algorithms which had been used in other domains and other application areas. So that's how we got our start. And at this point in time, we have a couple of clients, and we are expanding our client base very rapidly with VC funding coming on board. And our clients say that what is most exciting to them is the ability to turn around engineering drawings in 1 or 2 days, as opposed to the 3 to 6 weeks that it currently takes them.
Yeah.
So it has dramatically reduced the number of manufacturing non-conformances. In addition to that, it has also reduced the cost of generating drawings by more than 50%.
Wow. That sounds amazing. That's really fascinating. My first job actually when I left college was doing these exact type of drawings actually, and I spent half of my time creating the 3D models, creating the drawings, getting told by guys in the factory that my drawings were all wrong, and that I had to redo them again, that I should take my dimensions from this datum, not that datum, all sorts. There must be like, hundreds or thousands of different options and ways that different manufacturing processes want the models drawn. How do you handle all that complexity? Do you focus on like specific verticals?
Yeah, that's actually, Vinod, his team was exposed to body and white assembly tooling first and developed essentially RPA configurations for that particular engineering domain. But it was also the case that the customers that were using this, the engineering integration, the manufacturing integration technology companies that do a lot of robotic automation design for tooling and assembly challenges, things like that. They also have to make sure that the output is formatted correctly for whoever the end customer is. So the OEMs all have their own design standards that the drawings have to adhere to as well. So what ingeniously I believe the company came up with was a way to essentially create autonomous robotic process automation configurations, and you can think of them as bots, individual bots, and each bot is essentially trained to recognize the engineering domain that the CAD modeling is designed for. So if it's for assembly tooling or for product design, it's essentially pre-configured to recognize all the features in that model, and then generate the drawings accordingly. And it's also configured to essentially make sure that the output adheres to the design standard of the end customer. So each time there's a change, and you may have a body and white assembly integrator in one part of the world that uses NX or Kettay for a GM program or for a BMW program. That's one robot or one RPA configuration. And then if we adapt that configuration to a different customer or to a different engineering domain, that's a different configuration. But once they're designed and set up, it can take anywhere from 4 weeks to 6 months to create a new RPA configuration for our automated drawing generation software to take over. And once it's initially defined, we use machine learning to help that configuration essentially get smarter over time and automate more and more of the process.
Wow, that's brilliant. So do you think, so when people talk about, kind of increasing productivity in manufacturing, I think probably most people are thinking about like improving like machine efficiencies. Do you think this is another piece of the puzzle then to improving productivity? I guess it's like reducing time to market for new products, or of iterating through design changes.
Yes, it definitely reduces the launch time. So it reduces the time to market by quantum of weeks. And in terms of actual manufacturing, it reduces the number of errors that get transmitted from the design process into manufacturing. So it reduces manufacturing overtime, reduces scrap, reduces rework, reduces the need to get into expedited shipping or expedited installation at the customer facility if it's tooling that's being considered. So there's a lot of benefits to manufacturing. And in addition, our software, when it comes to hole shots in the engineering drawings, we optimize the sequence in which the holes have to be drilled so that you actually the bot spends less time on the machining center for hole drilling purposes.
And one other critical component of productivity enhancement that can come from this type of RPA application is the fact that you're taking one of the most critical resources in the engineering design process, and that's the designer themselves, these 3D CAD engineers, and they're spending a small fraction of the time that they used to spend either inspecting drawings manually or making sure that the quality control has been adhered to appropriately. But they're also now have a significant amount of time in terms of the whole engineering team to allocate to better design and to do the work that most of them love in the first place. Very few people want to be in the process of being in what you had to do when you first started your career. Like, hey, go get the drawings ready. That's, it's a tedious, time consuming, repetitive, mind numbing kind of task. And so to put that on a robot, a software robot, a bot, is absolutely a big productivity booster for the time and value of that critical resource of your design team.
Yeah. Yeah, absolutely. Yeah, I got out of that role as soon as I possibly could back in the day. Could we take a look at it then? I'd be really interested to see what this looks like.
Yeah, let me share my screen here. I've got a, let me find out where it is here. There it is. So let me know if you can see that. Can you see my screen?
Yeah, I got that.
I'll go back here. So Vinod, why don't you can describe what's going on here?
So this is what you see on the screen is a part commonly known as a blade in the body assembly tooling world. And blades come in infinite sizes, shapes, and geometric variations. And our software this is just an example of what our software can do. Our software can do this for any kind of mechanical part or assembly. And what's going on here is it initially picks all the datums appropriately depending on the manufacturing process for each feature, and then dimensions each feature relative to its specific datum. And then what you see now is the holes being numbered in a sequence that will enable the part to spend the least amount of time on the machining center. So there time is money there. And what's going on here is that the actual hole coordinates are being shown on the engineering drawing, and at some point in time we could potentially port these hole coordinates directly to the CNC G code, so the NC programmer does not have to manually input these and risk creating errors while the input is going on. So that gives you a very quick synopsis, and this is clearly a fairly simple part in the big scheme of things, and we have done this for far more complicated components and assemblies than what you just saw on the screen.
And what you're seeing there is running autonomously. Typically the workstation that it runs on, and that was an NX example there, we've configured for Kettay and Inventor, and are in the process of configuring for SolidWorks. Any API kind of exposing CAD platform that essentially allows us to integrate this technology is doable for us. And what you see there is essentially a process that typically runs overnight on an unattended on a workstation. So it takes advantage of this sunk cost that everyone's put into the design process and turns it into a workhorse to just get the drawings done. So the analytics that and essentially made all that automated drawing generation possible happens entirely in the cloud. It's an AWS based core processing engine, but there is a simple plug-in toolbar that's expressed on the workstation that the designer uses to set the model up, and then essentially press a button, go home, come back in the morning, and the drawings are ready.
Yeah,
and it can also support 3D annotation as well. We don't have to output it to a drawing format if the client wants just an annotated 3D model with all the dimensions and datum flag locations, datum locations and things like that pre-selected. It can essentially render that on the model too.
Yeah. Okay. That looks really good. That's really cool. Yeah. So how did you come up with this idea then? Where did it come from?
It was driven by need. When we got into business in 2005, we were growing like so many other companies in the outsourced design space. And at that time in 2005, our sole value proposition was lower cost engineering, because we established an engineering center based out of India. But these obvious errors or issues that we talked about in terms of chaos, errors, and there's a lot of back and forth that happens in the conventional drawing creation process. As we discussed earlier, our customers were mostly in Michigan or in Western Europe. They would create the 3D CAD models for body assembly tooling and send the files over to our team in India.
Mhm.
And our team in India would find that there were a lot of errors in the 3D models, which caused errors in the engineering drawings. And
Mhm.
then there was also human error from our side in India. And those errors would hopefully be caught by the QC or checking team at our customer's end. And they would mark up the engineering drawings and also mark up a bunch of 3D CAD model changes that needed to be made. And then they would send this back to our team in India. They would make the 3D model changes, fix their drawing errors, and redo the drawings to an extent because something in the 3D model changed. So this was just a painful process, and everybody in the world accepted this as status quo because nobody knew how to do anything differently. So
Mhm.
we were just another one in the pack. And that's when I decided that there had to be a better way, and we put in a lot of research and development and found that there were certain APIs associated with the CAD platforms like NX and Kettay and so on that would enable us to automate drawings, but with a significant investment on our side in terms of specialized algorithms, which would essentially create the end product of the engineering drawings. So
Mhm.
that's where the idea came from, and we went live several years ago, and then we figured out how to make our software very configurable for any kind of engineering domain. As we mentioned, we started out with the body assembly tooling domain, then we've expanded into powertrain assembly tooling, and before that, we started with General Motors PIW standards, and then our customers paid us to expand into various other OEM standards. So now we have configurations which run for Volvo standards, Daimler, Fiat, Chrysler, or Stellantis as they're called today, and so many various OEM standards for body assembly tooling. And we're just launching in the area of powertrain assembly tooling. We are also going to be launching for a company that makes plastic components for automotive applications. The list goes on, and automotive sector is just a beginning for us. We've been talking to companies in the aerospace and defense sectors, heavy industry, the two-wheeler industry, and there's just everybody has the same pain points. It's really no different. The bridge between engineering design and manufacturing is essentially a chaotic process, and that's what we are out to fix and make life easier for our clients so that they can focus on what's really important in terms of designing their products in an optimal manner and being able to manufacture them with the least amount of chaos.
Yeah.
Now, I would add that one thing that I describe as the newcomer to the scene here. I've only been with the company a couple of years, but there's a lot of R&D that's embedded in the platform that we refer to as essentially it's robotic process automation as a service. So it is a complete end-to-end rethinking of the process that would be required to do this kind of automation. It's not simply a series of CAD optimization or tinkerings for drawing improvements, little pieces of the drawing generation process. It's an end-to-end automation solution that does require that you have to think like an engineer more than a CAD software developer. And so we have, for each configuration that we deploy, in-house expertise, but also embedded customer expertise in terms of the design scenarios that our algorithms are going to have to understand and process. So it's a pretty heavy investment in terms of the intellectual property behind the algorithmic processing of these abstract 3D CAD models. And it's very powerful and flexible. So as Vinod pointed out, our plans are to go into aerospace and defense, but we're not stopping there. We can easily render architectural drawings and plug into something like Revit with enough training models for our algorithms to automatically examine and detect So that's really when I say when I tell customers it's essentially a turnkey solution, it really is. It's you have your CAD platform, you have your engineering domain, we can set up software robotics, essentially software robots to essentially automate that process end to end.
Wow. So at what point does it make sense to do robotic automation? Is it should everyone be doing robotic? Should everyone be doing it, or is it number of engineers or the percentage of the time that they spend doing this repetitive work?
Eventually, I think it does make sense for almost any engineering design task. For at least from our perspective, it's mechanical components and systems, right? This is a mechanical engineering solution. Not for hydraulics and things like that. But you definitely in that design scenario, especially if 2D is a bottleneck, and if it's a time-based bottleneck or a sheer volume of amount of drawings that you have to generate. So for complex tooling that has thousands of components, each one needs its own detail view, each one a different view angle and everything else like that. Those are the tedious simple calculations that we can do algorithmically. And that's where it really makes sense to say, why are we spending all this time and effort? Whether it's outsourced or not is really less the question of how much work is there. And then there's, in the case of a plastics components manufacturer we were talking with, they get design changes from the customer up to the last moment. And then they have this big 2D bottleneck that they got to go finish everything in the final form. They'd like to be able to essentially test some 2D output to go to pre-manufacturing or in their manufacturing design and have those drawings to work with, and then redo them again if there's a design change at the last minute. So in that scenario, it definitely it's a big game changer to be able to essentially press a button and get drawings, as opposed to pack them up, ship them out, get the drawings done, error check them, and then release to manufacturing. We have a design change, start all over. So in that context too, I think the time or the volume of 2D work, that's where we come in and can provide significant benefit.
Yeah, sure. Okay, brilliant. It sounds exciting time for you guys. Have you got any big plans for next year, for 2022? What's on for you?
It's things are roaring back with our customers, but I'll let Vinod speak to some of the product ideas that we have on the horizon and our plans for additional configurations. But from my perspective, I'm most excited to see just the amount of engineering capacity that we're helping to boost with our customers. These are guys that are teams that are doing 50 to 100,000 hours of 2D annually or more, and we're building configurations to put all that into automation. So, all right, Vinod, do you want to talk about some of the product and new configuration directions we're moving in?
Sure. So based on what our customers who are coming on board and our existing customers have been asking for, they want a configuration built out for SolidWorks, another one built out for Creo, and we'll have another one built out on AutoCAD as well for a company that designs plant layouts and plant engineering systems. So that's our main thrust, and we're also going to be bringing on new customers. We spent quite a few years just focusing on a couple of key clients, and we finally opened up the door to bring on new clients, and we have quite a few who are coming on board as we speak, and we want to be able to bring on a whole lot of customers, and we're going to be working directly with the automotive OEMs and have them introduce Auto 2D, which is our product, to their suppliers. So that's the best way for an OEM to gain the benefits, is if all or at least the critical suppliers are using Auto 2D in their day-to-day operations. So that's our plan for 2022.
Brilliant. Sounds really good. Hope that works out great for you guys. If people want to find out more, what's the best way to get in touch with you or to find out more?
Brian?
Vinod, if you want to give them the email address. I don't know if we had if there's, I think you have we sent that to you.
Okay, if it's an email address, we can put that in the comments section below the.
That's probably the easiest.
Sure.
And or you can reach if you type in sales at vectraglobal.com, sales at vectraglobal.com, that will get to me, and I would love to speak with you. But we are also very open to essentially running full demonstrations of the software using CAD files from customers, provided that it is closely, proximal to the configurations we have already created. We can typically take, an example a file and show a customer or potential prospect what it would look like to have that fully automated and what the steps would be required to complete the configuration. And we can do that in a day or so. So it's not really something you can go download and start using. It is highly configured and but very powerful software. But yeah, we can set that up. So yeah, either sales at Vectra Global. I thought we also have an email address called podcast. Is that right? At Vectra Global?
I think you did set that up. I think you're going to ask Anand about it.
Yeah, but for sure, sales at Vectra Global will get to me, and info at Vectra Global as well. And we respond immediately. So
okay, brilliant. Okay, well, yeah, thanks for your time, Brian and Vin. That was really amazing to hear all about what you guys are doing. Sounds really exciting. Hope you guys have a great day.
Absolutely.
Thank you, Martin.
Take care.
Take care.